So Javon is looking for an even better method of establishing that triangles are congruent, and he's looking at the set of triangles below. Javon thinks that triangle EFG, let's see, that's E up to F, E to F to G. He thinks that's similar to triangle HIJ, but he's not sure if the triangles are drawn to scale. Read the math notes box in this lesson, and we did read those yesterday, but they're suggesting that you reread those again. It says, on your paper, sketch the two triangles at right and label them with the following information. So we're going to set some of the sides so that they're equal in length, and we're going to set a couple of the angles both to 87. And then one of the angles, angle F, we want to be have it 25 degrees, and angle H is going to be 68 degrees. And so we're supposed to convince Jovan that these triangles are congruent. So what I'm going to do, and it's a little confusing, but I am going to use this kind of generic similarity tool from CPM, not this one, this one. And the problem is I'm not able to relabel these, and there's probably some simple way of renaming the points, but I can't figure it out. So if anyone can figure out how to relabel these, I'd appreciate it. But I do want to go ahead and do what they said. So excuse me. In the diagram, they had measure of angle J and G are both 87 degrees. So you can see where J and you can see where G are. So I'm going to set those two angles. I'm going to connect them. I'm going to link them and try and get them close to 87 degrees. So what you do is here it's C, so I'm going to link this one with this, and I want them to be close to 87. So I'm just going to pull it down. So you can see they are both 87 now. The next thing that I'm going to try and incorporate is two of the sides. It says sides IJ, that's along here, the bottom, and FG over here are 13 long. So IJ and FG. So let's link those two sides. So again, to link it, I'm just going to click this and drag this link over to here. Now you can see neither one of them is 13. So what I'm going to do is I'm going to kind of drag this, try and make it 13, and I don't want to change this angle. It's 87. So okay, I've got it just at 13. You can see I've messed this angle up, so I'm going to bring this back to 87. Now you can see they're linked, but this is 7.6 and this is 13, so they need to be the same. So what I'm going to do next is I'm going to scale this triangle up. So if I click this once, this is the scaling tool, so I can click it, and now if I think I click once to get the center of scaling, and now I'm going to just scale it, and I'm trying to go until this is also at 13, and there it's 13 right there. So kind of difficult now because these triangles are fighting for screen space, but you can see that I have got two sides of 13 and a 13, and the two angles that are 87. Now another thing that it said was that one of the angles was 25 and the other angle was let's see, what was the other angle? One was 25, angle F is 25 and angle H is 68. So if I come back here, I want to make this angle a little bit bigger. So I know if I just that's going to be tough because I can't change the length of this side. I want that to stay 13. So what I'm going to do is I'm just going to pull this nope, not that. I'm going to pull this up until there's 25 right there. And perfect. So that now is 25, and that is interesting because that's what the angle is supposed to be on the other shape. If you look at it, it said main angle F should be 25, and notice when I did that, that forced E to become, no, I'm sorry, I made F 25, and that forced this angle right here to be 68. And you'll notice that it's supposed to be 68 on this other diagram as well. So I can come in here and try and make this one a bigger angle. And I think to make it bigger, what I'm going to have to do is pull this down closer. So I want to keep this 68, but I'm trying to make this, or 87, but I'm trying to make this 68. Now, as soon as I stop there, let's look at the two triangles that we have. Notice it said that one of their sides, one side was 13, and there was a side in the other one that was also 13. We had an 87-degree angle, an 87-degree angle. One of the angles was 25, and in the other triangle, this one was 68. Well, notice what this does. Because it forced, if this is 87 and that's 68, it forces this one to be 25 because of the triangle sum theorem. If this is 87 and that's 25, it forces this angle to be 68 also because of the triangle angle sum theorem. So what we're looking at here are two triangles that are most definitely congruent to each other. And if I wanted to kind of lock it in place, I could go ahead and link this angle to here, meaning I will always want that to be 68, and link this one to here. And what I can say now is, look, it's not just that these two particular triangles, it's not that just these two particular triangles are congruent, and yes, they're clearly not drawn to scale. It's not just that they're congruent, but any time that we have information that's equivalent to that information, we end up with congruent triangles. So you can see now what I've got. I've got a side that's 9.9 and 9.9, and they have this angle that's 63 in each. One of them has a 36, and the other one has an 81. Well, that information forced these triangles to be congruent. Another thing that I can show you is, if I want to show you the transformations that get these triangles to line up perfectly, I could, for example, take this triangle and I'm going to just slide it over so that point F lines up with point B. So they're just right on top of each other. Now I'm going to rotate this one. So to rotate, you do a click, hit rotation. Next thing you get is this crosshair, and this crosshair is the center of rotation. So if I come over and say, look, I want to rotate about that point, I click it. And then if you pull your cursor away, you've got more control, more fine motor control. When you're really close, this thing flops all over the place quickly, but if you pull it away, a lot of mouse movement, very fine motor control over this. But you can see there's clearly now a point where I can rotate one right onto the other. So these two triangles are clearly congruent because I can show a series of transformations. First, a translation of point F to B, and then a rotation of some number of degrees that maps this up perfectly with it. And I'm not sure how many degrees that is, but we can measure that. So anyways, I hope this is kind of a helpful introduction. Let's look at the, so convince Jovan that these triangles are congruent. Well, I think one of the things is that, the 25 forces, if I've got a 87 and a 25, it forces this to be a 68. If I've got a 87 and a 68, it forces this to be 25. So the three angles in one triangle are congruent to the corresponding three angles in another, and they both have this one side that's 13 that's between the angles that measure 68 and 25. How many pairs of corresponding angle measures need to be equal to be sure that the triangles are congruent? Well, I would say probably just two, because if I have two angles in one triangle congruent to two in another, it forces the thirds to be congruent because of the triangle angle sum theorem. And then it says, what is the minimum amount of information you need to determine that the two triangles are congruent? Well, it looks like a couple of angles and maybe a side, at least one of the corresponding sides. So we'll leave this video at this point right here.